The primary motivation for our project was the problem that 200 to 300 gallons of water are wasted per day in the average U.S. household due to leaving the water running. Water only costs 15 cents a gallon in the U.S. However, in developing countries, this wasted water adds up to an exorbitant amount of money. Another issue is that our current hands-free solutions are often inconvenient. This is due to issues with accurately sensing human interaction, short lifespan, inconvenient maintenance, and sensor-activated faucets have actually been shown to use more water because they turn on the valve full force and don't have any option to use less water.
This is a fully integrated version of our design. The 4 design blocks include the actuator, solenoid valves, the circuitry, and a power source. The actuator is a mechanical pressure mat with force-sensitive resistors that is activated when somebody is standing on it. The solenoid valves that receive electrical signals to open or close control the flow of water in the hot and cold water pipes before the water reaches the actual valve sink. The circuitry sends signals to the valves, and the power source is a DC wall plug-in converter.
This is our final prototype of the mat. It consists of 2 sheets of polycarbonate held in place with bolts and washers. We chose the polycarbonate as our material for the mat because it's durable and will not crack under the weight of the user. In between the sheets are 3D printed discs. When the user presses down on the mat, the flex of the polycarbonate sheet presses down on the 3D printed discs, which then activate the force-sensitive resistors.
As Alyssa mentioned, the mat presses down onto the force-sensitive resistors, which as the pressure increases drop in resistance. This resistance drop is what allows us to use them as buttons in our circuit. The FSRs are directly connected to the Itsy Bitsy microcontroller, which reads the voltage change across the FSRs and then sends a 5-volt signal to the relay module, which allows for 12-volt DC power from the wall to go to the solenoid valve. In this video, you can see a red light which indicates the relay firing. We included a reset button due to some issues we encountered during the testing phase.
As our main valve, we used a brass solenoid valve that takes in 12 volts of input and flows only one way. We started with a plastic prototype, but ended up going to this brass prototype, which has no minimum pressure requirement.
This is a video of our device in use. The user turns the sink on using the tap and stepping on the mat. Although he forgets to turn the tap off, the water stops flowing since he has stopped pressing on the mat and has walked away.
When he returns, he presses on the mat to resume the flow of water. However, when he turns the tap off, the water does not run even though the mat is still being stepped on.
Of our 6 design criteria, we were able to meet 5, with 1 currently being tested. In regards to safety, all of our product conforms to FDA and RHS standards, and the circuit is completely waterproof, housed in a plastic box. In regards to durability, we had 5 people of different weights stand on the mat and use the device 20 times. The structural rigidity of both the circuit and the mat were maintained. In regards to cost, the cheapest calculated manufacturing cost based on currently available online prices is $53. Our target was $50, so we came very close to meeting this criteria. In regards to ease of installation, we had 10 people install the device and give a closed-ended survey at the end of the installation that rated how easy it was to install. We found that these 10 users found the device easy to install with an instruction manual and basic toolkit. 5th, we had enjoyability. We had 30 people use the product and give an open-ended survey rating their enjoyability of using the product. We found that most of the 30 people found the product enjoyable to use. Lastly, we're testing subtlety in the kitchen. We will give 20 users a 15-second period to observe our sink setup where the product has been installed. Based on the psychological phenomenon of primacy and recency, we'll be able to determine how subtle in the kitchen this device is.
One of the main concerns our product faced when meeting our design criteria was not having an override feature. So in the future, we plan to include one, using a simple on or off switch or button. This would be easy to implement, however, due to time constraints, we were unable to add it in the final prototype. We also plan on making the design more aesthetically pleasing and waterproof by adding a 3D printed box to house the circuitry. Lastly, we plan to integrate the design using an actual kitchen sink mat with the pressure-sensitive sleeve.